class. I'll be your sub for the next 2 weeks. What are we gonna do while she's gone? I'm gonna be teaching you the laws. What kind of laws? Well, we're going to be doing Boyle's Law, Charles' Law, and Gay-Lussac's Law. Well, let's start with Boyle's Law. It states that at a fixed temperature, which means the temperature stays the same, then the volume of a gas is inversely proportional to the pressure exerted by the gas.
Can you say that in a way that I actually understand?
So basically, as pressure increases, the volume decreases. Here's a balloon. If I step on it, what do you think will happen?
It will pop!
Correct, because of Boyle's Law. Now, come and watch this. Children, gather around. Okay, there's a balloon placed on the floor. Now, when I step on it, the volume is being decreased, and this balloon here, well, it has a pressure point. And when that pressure point is exceeded, the balloon will burst.
Cool, do another!
Okay, well, let's do one with some marshmallows.
Ooh, yum.
We're gonna use a syringe and try to expand and shrink these marshmallows. These are marshmallows from Walmart. They are fun, fruity flavors, but you can use any kind. Okay, first I'm gonna put the syringe together. Might have to get close, children. Okay. Now I'm gonna put my finger on this so pressure or air won't escape. Now, once I pull this out, the marshmallows get larger. Now, if I put pressure on it, they shrink. Okay, now you try.
Oh, woohoo! Ooh, they got bigger. And now they shrink.
Well, that was enough of Boyle's Law. Let's try some Charles' Law. Okay, we're gonna use soap. What we're gonna do is we're gonna microwave it. Now, what do you think will happen if we microwave ivory soap?
I think it'll melt.
Melts? Well, let's find out. First, we're gonna put the ivory soap in the water. It floats. This other soap sinks because the ivory soap is less dense. Okay, well, now we're going to heat the ivory soap. Now this one's less dense, which causes it to easily expand. So let's see what happens when we put it in for 1 memento on a paper towel, just in case. Now wait. As you can see, the ivory soap is indeed expanding. That's because these microwaves cause air and water molecules to react inside the soap. They move apart in opposite directions. Tiny air pockets swell, and since the soap is warm, the increasing air and water molecules can easily push out the new formed substance.
It's done!
Ooh, and there's the soap. It's a lot bigger than it used to be, but really the mass is the same.
Wow, I'm gonna go home and show my mom!
So V1 over T1 is equal to V2 over T2. That's a direct relationship. Now, let me put this in perspective. It's like a hot air balloon. Now, for example, this hot air balloon, which is totally realistic. Warm air rises in the cool air. Hot air is lighter than the cool air because it has less mass per unit volume. That's where volume and temperature come into play, if the pressure is constant. Which is why there's fire, usually right there, blue fire, Sure. In the hot air balloon. Now it's time to get a little dangerous. Safety first. Now, children, come around the stove.
Turn the heat on.
Put a teaspoon of water in the empty can. So maybe it'll equalize the pressure a little bit. And place it on a hot stove. Okay, now we're gonna leave it until we see a little bit of vapor coming out. Well, water and air molecules are moving rapidly, so the molecules exert enough pressure to keep the can from being crushed. Now, after it heats up a little bit, we're going to turn this upside down and place it in the water. Okay, it's about time to turn it upside down. Alrighty. Well, let's do this the right way. Whoa! Look at it. It's crushed. Soda joke. Well, the molecules are cooling, so that slows it down and condenses the can because they no longer exert enough pressure inside the can to withstand that atmospheric pressure. Like, whoa, science.
So cool!
This is gay lussac law. Now, P1 over T1, P stands for pressure, T stands for temperature, is directly related to pressure 2, temperature 2. Okay, let's try a little experiment. Now let's turn the can upside down. Let's see what it does. As you can see, the volume of the water is slowly going down. That's because the air pressure inside the can is sucking it all up. Wow, look, all the water is gone. The temperature in the can decreases, so does the pressure. So the can wants to stabilize. That's why it sucked up the water. You guys understand the laws?
Yeah!
Okay, students, now for your homework, I want you to figure out what law this is. This regular Coke had a balloon placed, as well as this Diet Coke. But after 4 to 5 hours, this balloon is filled up some, and this one's still flat. Why do you think this happens?
Homework.
Well, thank you for having me. I know you missed Miss Craig's, but I'll be back again tomorrow. Stay cool, kids. Eat your veggies and all that.
Bye, Miss Coons. Oh wait, oopsie this. Bye, thanks for watching. I love